In Lesson 2-3, you will be solving multi-step equations. Our first example is 11x minus 4 equals 29. First thing we're going to do is draw our train tracks. And then remember, we are going to undo everything that's been done to the variable. So first, the variable is multiplied by 11, and then we took 4 away. So the first thing we're going to undo is the minus 4. To get that to disappear, we want to add 4, because a negative 4 plus 4 is 0. But if I add 4 to the left, I have to add 4 to the right to keep it equal. So on the left side, I'm left with 11x. And on the right side, I have 29 plus 4, which is 33. Now we need to undo the multiplying by 11 by dividing by 11. 11 divided by 11 is 1, and 1 times x is x. And 33 divided by 11 is 3. Now remember, with equation solving, you can always check your answer by plugging it back into the problem. 11 times 3 is 33. 33 take away 4 is 29, so we know we have the correct answer. The next example is a little bit different, and sometimes students have a little bit of trouble with this one, so watch carefully. You draw your train tracks, and again, we're going to undo everything that's been done. We're going to work in reverse order. The first thing that was done to A was 7 was added to it, and then it was divided by 8. So we're going to undo the dividing by 8 first in this problem. We undo dividing by 8 by multiplying by 8. And then what happens here, when you divide by 8 and then turn around and multiply by 8, you end up right back where you started with A plus 7. And then 5 times 8 is 40. Now to get the A alone, we want to get rid of this plus 7 by subtracting 7 from both sides. Positive 7 and a negative 7, when you add those together, you get 0. And A plus 0 is just A. And on the other side, 40 take away 7 is 33. Now to check your work, you take this 33 and plug it back in for A. 33 plus 7 is 40, and 40 divided by 8 is 5, so we do have the correct answer. The reason why this one is a little bit tricky for kids sometimes is because it was reverse the way that we went through it. In this example, we went add and then divide, and in this one, we multiplied and then subtracted. It's because of the way the problem's written. This fraction bar is sort of like a grouping symbol. You do what's on top first and then divide by 8, which means the dividing by 8 is the first thing we have to undo. You may want to pause the video and try the next 2 problems. All right, draw your train tracks. Now to get the A alone, we have to first get rid of this minus 6. To get rid of the minus 6, we're going to add 6 to both sides. This negative 6 plus 6 is 0. So we're left with 2A on the left and 4 plus 6 on the right. 4 plus 6 is 10. Now we're going to undo the multiplying by 2 by dividing both sides by 2. And we end up with A equaling 5. Now let's check that real quick by plugging it back in. 2 times 5 is 10, and 10 take away 6 is 4. Our next example, it's like this one right above here. You want to undo the dividing by negative 2 first. So we're going to multiply by negative 2. So this divide by negative 2 and multiply by negative 2 will end up canceling each other out. So you're left with n plus 1 on the left, and then 15 times a negative 2 is going to be a negative 30, because remember, one of each sign when you multiply is always going to be negative. Now to get the n alone, we have to undo the plus 1 by subtracting 1. So the plus 1 and negative 1 is 0. You have n equals, now a negative 30 take away 1 is negative 31, or you might want to change it to adding the opposite. Negative 30 plus a negative 1 is negative 31. Now if you want to check that, you go back here. Negative 31 plus 1 is negative 30, and then negative 30 divided by negative 2 is going to be a positive 15. Our next example is one where you need to write the equation and then solve it. Hiroshi is buying a pair of water skis that are on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $115. What was the original price of the skis? Write an equation for the problem, then solve the equation. Well, what we don't know is the original price, so let's have P equal the original price. Now let's go back and read the problem and see if we can write the equation. Buying a pair of water skis that are on sale for 2/3 of the original price. If the original price is P, 2/3 of the original price would look like this. 2/3 P. After he uses a $25 gift certificate, so we're going to subtract $25 off of that, the total cost before taxes is $115. So now this is the problem that we want to solve. Draw your train tracks. The last thing that's been done to the variable is minus 25. So we're going to undo that by by adding 25 to both sides. So on the left side, we end up with 2/3 P. And on the right side, we have 115 plus 25, which is 140. Now, if you remember from earlier, when you have a fraction attached to the variable, the quickest way to get rid of that is to multiply by the reciprocal, because a number multiplied by its reciprocal is always equal to 1. So over on this side, the 2's will cancel, the 3's will cancel, those will all become 1's, and 1 times P is just P. On the other side, I'm going to write that 140 as a fraction, 140 over 1. Now I can do some simplifying ahead of time to make my life a little easier. 140 and 2 both can be divided by 2. 2 goes into 2 once. 2 goes into 147 times. 70 times. And then 70 times 3 is 210. And 1 times 1 is 1. 210 over 1 is just 210. And we are talking money here, so let's say $210 was the original price. To check your work, you would put it back in right there. You would want to say 2/3 times 210 minus 25 should equal 115. All right, our last example is about consecutive integers. Consecutive integers are integers in counting order, such as 4, 5, and 6, or n plus 1, and n plus 2. Counting by 2 will result in consecutive even integers if the starting integer n is even, and consecutive odd integers if the starting integer n is odd. Write an equation for the following problem. Then solve the equation and solve the problem. Find 3 consecutive odd integers with the sum of negative 51. Well, if n is our first odd integer, our next odd integer is going to be n plus 2. Because, like, for example, if n were 5, the next odd integer is 7. So we would have to add 2 to what we started with to get there. And then our next one would have to be n plus 2 more than we had there. So it's going to be a total of n plus 4. So if we want a sum of negative 51, it's n plus n plus 2 plus n plus 4 equals negative 51. Now, before we begin to solve it, we're going to simplify this a little bit. If I have n plus n plus n, because remember I can rearrange the order due to the commutative property of addition, n plus n plus n is 3n. And then 2 plus 4 is 6. So I really have 3n plus 6 equals negative 51. Now to solve this equation for n, I want to get rid of this plus 6 by subtracting 6. So on the left side, I have 3n. And on the other side, a negative 51, take away 6 more. That's a negative 57. If you can't see that, you might want to change it to adding the opposite. Negative 51 plus a negative 6 is negative 57. Now you want to go and divide both sides by 3. 3 divided by 3 is 1, and 1 times n is n. And on the other side, a negative divided by a positive is going to be a negative. And then 57 divided by 3, that's going to be 19, or negative 19. So our first odd integer is negative 19. Now be real careful with your next one. Oftentimes kids make a mistake here and want to say negative 21 next, and that's not the case. Because if this is my first one, this is my second one, this is my third one. So if I want to get my second odd integer, it would be negative 19 plus 2. Negative 19 plus 2 is actually negative 17. And then my third one is negative 19 plus 4, which is negative 15. Now, if you wanted to double check yourself, you would take all 3 of these integers, add them together, and they should total negative 51.